y'all.
Today. Oh my
Because
goodness.
I promise my sofa feel one of them sofas. Oh my gosh. Not the formal one, not the one your grandma be like you don't really sit on and sleep on. The other one.
That one with the plastic still on it.
Yeah, not that one.
What y'all know about that?
Yeah, with the flowers.
Yeah, with the flowers. Right. Yeah, I mean that. Hey.
Are y'all talking about my living room furniture? Stop it. Because I'm the type, if it's not broke, don't fix it. Okay.
You have taken the plastic off, though, Miss Cheryl. We know
okay, I still have the tags hanging underneath these
underneath the pillow.
Y'all been looking at my home. Stop it. You sound like my mother.
Oh,
Isn't it time to get some more furniture?
Does it say Ashley Furniture? Does it say Ashley?
No, this is that what you call Sweetwater furniture. I don't know if anybody's familiar with that.
Hey, respect to that, for real.
Yes, I don't know if anybody's familiar with that term. When you just get married, you don't have a lot of money.
Yeah.
And so you gotta
And went to Rooms to Go, Miss Cheryl. And didn't they have that 12 months with no interest, no payment? Look. We got the whole house up the kitchen.
Look.
Well, nobody's in here anyway, so it's good.
Miss Mitchell got that birthday hairdo. I see you. We see you.
What had happened was I can't tell the secret.
Okay. I see you. All right. All right, everyone. Let's get started. Got a lot of ground to cover today. Hopefully, we can get through it pretty quickly. But did want to thank you all for took a brief look at the presentations. I'm really looking forward to them. I'm not sure if you all saw, I posted the final projects and the oral project to be presented in class on November 14th. So what I wanted to do is just quickly go through the remainder of the semester with you all before we get into our group projects or to our group presentations today. So as you know, today is October the 10th. We are dealing with a truncated schedule this year. So we will not be doing Pearson's R correlation or Spearman's rho. We will start that next week. And then the next week we'll get into regression. Hopefully we'll work through multiple regression. We may touch on linear regression on October 24th. And then we'll wrap up on the 31st on Halloween with regression. I am in the process of a move, so it is quite possible that we will not have class on October 24th. Just got to see how things materialize there. So we may end up doing all the regression on the 31st. We will still have, if we are not able to get through all the regression, we will have class on on November 7th, but it is only 2 statistical applications, so it's very possible for us to be able to get through it on October 31st. On November 14th, we will have the class presentations. You will be presenting an oral representation of your written quantitative research proposal. You should have gotten groups. I set Canvas to assign you to groups. I'm not sure if it has done so. Let me know how that works. I think I set you all up for six groups of 2. So let me know if that works or not. But yeah, that's the remainder of the semester. We will be, once we get into Pearson's correlation, we will be dealing with statistical applications that require both a continuous independent variable as well as a continuous dependent variable, or multiple dependent continuous variables on either side. this is still the case for regression. Regression and is an advanced form of correlation. So both independent variables and dependent variables will be continuous. So a lot of questions you can answer, research questions you can answer with both forms of statistical application. Today we will be doing one-way ANOVA, which is requiring a categorical independent variable and a continuous dependent variable. So we'll be looking at things like hair, socioeconomic status having an effect on a continuous dependent variable. So we'll be doing that after the presentation. So looking forward to that. And the reason and what distinguishes ANOVA from t-tests is the fact that ANOVAs have more than two categories in this situation. So you'll be looking at something like red, brown, and blue versus just red and blue in a particular model. Any questions about the final quantitative research proposal and or the oral presentation?
Yeah, I got an email last night, but I couldn't figure out how to open up to see what was in it. Did anybody else figure out? Angela did? Okay, cool. I'll get with Angela after class.
It's just under groups. So if you're on Canvas and you see courses and then under there it says groups, if you click on that and then click on Final Project 6, then that's where you'll see. And then once you get into that, then go to people. And there might be a quicker way, but if you go under people, you'll see.
Lord have mercy. Okay.
Well, Angela, does it show everyone? Can you tell everyone, or does it just show? No, it just shows who I get to work with, which I'm excited about. And then that's it.
I don't have groups, buddy.
Angela, can you share your screen and walk folk through this? I'm interested in seeing this myself, if you don't mind.
Is it in our email?
Collaborations.
Is it in email or in Canvas?
It's in Canvas from what I saw. I didn't even check my email this morning.
Okay.
I am very curious to see how this works, in theory.
Well, let me know. It says I can't share.
Yeah, hold on. Give me 1 sec.
Okay.
There you go.
Okay. Okay. So groups, Final Project, people. Wait.
So it's in your main navigation.
Final Project 6. Okay, mine say 4. Never mind.
Yeah, yours is gonna, depending on which group you're in, have a different number.
Okay.
I see what you did here, Dr. Moen. Okay. You trying to bring the fire with this final presentation.
Of course not. You guys have really impressed me with your ability to synthesize information and give it back. And so I'm looking forward today. We're together. Huh. Yeah, so I have all the confidence in the world that you will do well. Okay.
Nobody's going to rest till they see there, so we just might as well go ahead and tell everybody.
Yeah, I can't see it. So
I got Brady. Brady, if you're looking for it, it's me and you.
You got this.
I'm Frederick.
Canvas
You're my partner.
Canvas put all the stigmas together, so it's me, boy, you, and Terrence.
And nobody is in a group by themselves, right? By themselves. We have 13, so I figured there would be one group with 3. Cool. All righty. If there are no questions about the final project or the final oral presentation, let's go ahead and get into these group presentations, and I'm very excited about them. Now, here's one rule that I have for everyone. If you are not presenting, so group 2, you will be presenting second. If you're not currently presenting, you have a responsibility to ask at least one question during the presentation. Everybody from group 2 is required to ask a question of group 1.
That
mhm.
was not in the memo.
Yeah, I know.
Comments.
I know, but it can be a simple question. It can be a complex question, but yes, everyone has to ask a question during the presentation.
Group 1, are you ready?
He didn't say we had to know the answer. He just said y'all had to ask the question. So just
That was the question. Are you ready?
How long did you take to prepare your presentation? Just kidding.
Yes, we're ready.
So so I am going to, who am I giving control to?
That would be me.
All righty. All right, let's take it from there, group 1. I'm ready.
All right, good afternoon, everyone. We're excited to be with you today to really kind of talk about the foundations of statistics, from theory right up to descriptives. So
Mr. Mathis, is it morning or afternoon?
I
morning,
wanted to say that, but I wasn't sure who was to ask the question.
I'm sorry, I had to, man.
I'm about to mute everybody. Did you give me host?
please.
Like he's already in the afternoon classes over.
I have a long day ahead of me. Good morning, everyone. So today you have with you LaShawn DeCarver-Moore, Terrence Green, Angela Hill, Vonda Martin Jenkins, myself, Maurice Mathis, Cynthia Simons, and Frederick Thomas. What we're going to cover today are these 7 items. We're going to talk about theory. We're going to talk about research problems and research questions. We'll then move to variables and levels of measurement. And we'll talk a little bit about hypotheses. And then we will finish up with measures of tendency. And then we're going to do a smooth handoff to the next group so that we can continue with the rest of the information. So first, we are going to talk about theory.
Okay, good morning. Today I'm going to speak to you about theory today, which is one of the major components of research, of the research process. Theory is known as the beginning and the end of the scientific research process. So theory may be defined as interrelated variables formed in propositions or hypotheses that specify the relationship among variables in terms of magnitude or direction and presents an explanation of the phenomenon behavior. That's a really thick definition, but a regular language definition is that theories provide explanations and connect stories about why acts, events, or behaviors do occur. In quantitative research, it can appear as an argument, rationale, or conceptual framework, and it explains, predicts, or expounds upon the phenomena or behavior. But to sum it up, theories explain how and why the variables are related, acting as a bridge between or among the variables. You can go to the next one. So in this one, in quantitative research, theories can be found in several forms. So there's 3 different forms that we can look at today. The one that we talk about a lot is hypotheses. But what about hypotheses, what they are, they're interconnected and show a process. So an example that I have up here is that the presence of a mentoring relationship does not influence first-generation students' intention to remain at their university. They also come in the form of if-then statements. So if you've been to an English class or you're an English teacher, you know what if-then statements are. They are a form of inferences. And so when you look at if-then statements, what they do explain why the independent variables influence or cause the dependent variable. Mm-hmm. So if you look at the word if is really like the hypotheses of the piece, like what can be seen here. So if it says, if the frequency of interactions of 2 or more persons increase, then would be the conclusion, which means the degree of their liking for one another will increase. And those are if-then statements. Also, it comes in the form of visual models. And visual models, this is just a sample of what one could look like. But if you look at a technical visual model, it is really detailed, and it talks about how the variables are related to each other, but it's not written as a hypothesis or if-then statement. It's clearly visual, and it's very easy for you to see.
Ms. Carver Moore, can I ask a question? You mind going back to the previous slide? Could you, so I'm looking at your hypothesis as a base of a theory here. Could you tell me or just share with me how that would look in, so before we get to the theory, we generally look at a real world phenomenon. What kind of phenomenon could you provide that would explain that hypothesis? So what would precede that theory? What would you observe in the real world that would bring you to this theory?
Well, for me, I guess I'm thinking about what would happen if you have students who are graduating from school or going to school. Do you have someone in your life who may be an influence to you, who will mentor you to keep you guided towards your intention to stay in school? Because a lot of times first generation students don't have, their parents didn't go to college. So who influenced them to go to college and remain there?
So let me ask a more specific question. What is the research problem? What's the problem that we would see in the real world that would prompt us to want to study this?
I would probably say that for this one, maybe first generation students are not staying in college.
There we go. That's it.
You're looking at first generation persistence and what influences that.
That's it. So what I want you all to be able to do is once you leave this class, to be able to look at problems in society, problems in your jobs, problems in education, and be able to take the next step and say, oh, okay, I feel, because we already do that a lot of times, especially when it's something near and dear to our heart. We're like, oh, well, this is going on. And let me, I wonder if this is the case. That's actually drawing up a theory right then, and then depending on how you draw the theory up, then it's testable. Got a question from Mr. Brady Davis. He wants to know, is the visual model created after the research, or is it created before and after, like the hypothesis? And the whole group can answer this. We don't have to make Mrs. Moore do that by herself.
But we will.
I know he said no, we will. When I look at it, actually, to me, it can go both ways. If they didn't have the word improve for communication skills, I would probably say that it was after, before. But to me, I'm thinking that online social skills online social games improve communication skills and makes you a rule follower and self-control. But the way they have the arrows pointing toward it, it kind of gives you the opposite direction, that if you have these things, then you could be well in online social games. This was actually a study that someone put together about how online games can actually make you a better communicator. To me, I would say that's the opposite, but according to the study they had, they found that it can be a better communicator and you have better relationships and follow rules.
And Mrs. Mitchell, birthday woman, asked is this directional or non-directional?
Okay, she would ask that one. I don't know.
Well, that first one,
it was just your hypothesis. The presence of a mentoring relationship does not influence first generational students' intention to remain at their university.
Non-directional.
Thank you, Maurice. Thank you for that.
All right.
All right, so the next thing is about looking at a theory and choosing a theory. Theories are testable, and one thing about testable, what that means is that the theory is tested under new circumstances that are independent of the original problem. When it's falsifiable, a theory should be potentially disprovable. By being tested or explained by new data. Also have significant phenomena or behavior, and what they mean by that is, does it have observable facts or events, and give a clear and plausible explanation, which means simply is it true or valid? And also it stimulates and guides further knowledge. And then I put at the bottom, which was a summation of the things on the top, is that theories cannot be verified absolutely and forever. However, they can be falsifiable. For example, they can be proven to be wrong given a degree of certainty or probability. All right, so this one what got me. I was interested in this one because when we start to look for our topics, it talked about the breadth of theories and the different types. So I had to look them up to see exactly what this was talking about. So they have something called macro theories, which explains broad trends at large levels, such as like social institutions, cultural systems. And so one of the examples that I found was something called conflict theory. And I had never heard of conflict theory. So I was trying to think of what are ways that we can look at education. So in this one, theorists look at the unequal distribution of resources, such as money and power, education, and social prestige. So like in education, this can be seen in inequities shown in materials, what topics teachers teach. That would be like a macro study. And then they have micro. And the example that they had was social exchange theory. So this one was a little bit more difficult to find, but this is what a lot of times what we will do something on, because you're going to use surveys and questionnaires, and you're going to look at small slices of time or people. So inside of the social exchange theory, it's about a theoretical explanation that social behavior is the result of an exchange process. So one of the things it talked about as a school principal, if you can get more out of a study was that you can get more out of your teachers based on the principal's behavior. So if the principal's behavior is a certain way, you can have teachers to go beyond their basic job description. So that will be like a micro study. A meso study was a little bit different. This is like a combination. So this one, it has something called the role balance theory. And this one was really difficult to research to find about, but it's a link between macro and micro. So when you look at this one, it was the role balance theory. So the study that they had at the University of California was that they took people that were, I want to say they were the youth playing in a like a baseball league, their parents, the coaches. They took all of these people and they surveyed them, and they tried to figure out for gender bias and for hierarchies in gender. They found that the people who were actually running the league were the people that actually created the gender biases and hierarchies. So that is what meso theories are.
Hey, I need to have a question for Mr. Phil. Look, I'll be murdering your last name, man, so I'm gonna have to call you Mr. Phil. But how many plausible facts should a theory have for it to be valid?
He's asking me something I have no idea about.
We'll have to look at that, and Mr. Boye, we will get back to you.
Boye. And you will come up here today, so just remember that.
I thought that was an easy one. Sorry.
They coming for you, bro. They coming for you. All right, very good.
I'm almost done. So I wanted to give some examples of common theories of what we see in education. And I thought, we have to really think about what's going on in our schools. And a lot of things that we do are based off education. I could have put a whole bunch, but one of them was the achievement motivation theory, and where people have a tendency to strive for success and choose goal-oriented activities. And so right here, an example that we have is the award ceremonies and valedictorians inside of schools. That's an example of achievement motivation theory. And the hypothesis here is there's a positive relationship between achievement motivation and success in school. Then you have behaviorism theory. We really knocked this one in school. That behavior that is positively reinforced will increase in strength. And so an example that we do in school is PBIS system. We believe that if on-task behavior will increase when teachers positively reinforce it. And then we have the Maslow's human needs theory. In a hierarchy of needs, people must satisfy their lower needs. So children from economically disadvantaged homes who are given breakfast at school will show achievement than similar students not given breakfast. So an example of this is where we begin to look at our breakfast and snack programs that we have at the school level. So quantitative theory. So now when we start to look at how we're going to write our research proposals and dissertations. And so I wanted to kind of talk about this part where researchers use theory deductively, which means making a logical argument or applying facts or logic. So we also have to place our theories close to the beginning of the proposed study. Researchers advance a theory by collecting data and reflecting on its confirmation and disconfirmation of the facts. So when we begin to look at our dissertations that we have to do is kind of set up on the next 4 bullets. The theory becomes a framework for the entire study, which organizes the model for developing the research questions or hypotheses and for the data collection process. And then, as you'll hear about later, the research questions contain variables that the researcher needs to define. The researcher uses an instrument to measure and observe the behaviors. And lastly, what happens, the scores from the instrument are collected and we confirm or disconfirm the theory. Right. And then the very last thing that I have here is for this one, where will we place everything inside of our quantitative study? And the quantitative study is dedicated to presenting the theory for the study. The theoretical framework is the structure that can hold or support a theory of a research study. The theoretical framework introduces and describes the theory, which explains why the research problem actually exists. So if you look on the right-hand side, what you will see is in regards to the theory, at the end of the study, the following things can occur. New research data can be interpreted and used for future use. We can identify new issues and create the critical research questions that need to be answered to capitalize on the understanding of the issue. We can also give old data new interpretations and new meaning in response to new research problems, which Vonda will come and talk about in a few minutes, that have no previously identified solutions.
Very good.
Thank you.
All right. Good morning, everybody.
Good morning.
Morning. All right. So as you just heard, your theory is pretty much going to, it's the framework. It's going to run throughout your entire study. And from your theory, you'll go into trying to identify a research problem. And so this problem isn't just any run-of-the-mill problem. This is a problem that really challenges and perplexes the mind. It shouldn't be a problem that you can easily go into a journal or go into a book and find the answer. It will, again, serve as the critical beginning of your process. So when LaShonda was talking, if you weren't already thinking about your particular research design, I'm going to go ahead and ask you to do that now. So when you were hearing about the theory, I want you to be thinking about, does your theory line up with what LaShonda just explained? And so now let's move into research problems. So I want you to honestly be thinking about the research problem that you've already selected, and you might find out something that you don't know. So according to Merriam and Tisdale, and if you have not run across this book, if you are doing a qualitative study, this is one that I would highly recommend, Merriam and Tisdale. Again, this is, your research problem is when you're taking something that you're most curious about, and then it forms the core of your research problem, reflecting the framework, and it represents a gap in the knowledge base. So you're gonna have to remember this. There should be a gap of knowledge that your research is going to be able to fill the gap. So again, you are identifying a problem, turning your general curiosity into a problem that you can address through research. You're going to have to find tons and tons of research that will go into your lit review that will support you choosing this research problem. Again, it's going to convey its magnitude and importance, going back to, this is not a general problem that anybody can answer. This is something that's going to require lots of time, a whole year and a half worth or more of extended time, and you're going to have lots of resources. All right, so when you first entered the program, you may have already thought that you knew you were going to do a qualitative, right? Or you could have said, I know I'm not going to do math, I don't want to do it. But honestly, you cannot identify your approach until you have identified the research problem. Because depending on what you do is going to lead you to if you're doing a quantitative or a qualitative. So group 2, I need for you to unmute your mics because I'm going to ask you a couple of questions. All right, so group 2, if you know that you're going to be conducting interviews and you want to hold some focus groups, what are you going to do, a quantitative or a qualitative study?
Mixed method.
Could be mixed.
Nah, qualitative.
Qualitative.
Okay, all right. So what about if you're going to measure variables?
Quantitative.
Quantitative.
Awesome. All right, what if you want to do some longitudinal designs? Yeah, that's not on your slide. I'm kind of throwing something else out there. A longitudinal.
Quantitative?
Absolutely. Good job, Tanya. All right. What about if you're doing a phenomenology?
Qualitative.
Awesome. What about grounded theory?
Qualitative.
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 So again, this underscores the notion that you don't pick your approach picks you, depending on what you're going to be studying and what your research problem is. Great job, group 2. All right, so now, if you're like me, you have a vivid recollection of one of our previous classes where we had to popcorn out, we had to go around and share what our problem was. And then Dr. Williams said, so what's the problem? You all remember that exercise? If not, I'm gonna refresh your memory because I see some blank stares. Brady, I'm coming at you first, all right? So Brady, remember,
I didn't have a blank stare.
that's okay. What was your look? Are you okay? Are you confused? You
I'm
just
good.
ready to participate? I got you coming, I got you, all right.
So Dr. Mon, this count for both groups, right? Since she's asking the questions to group 2.
Nah.
This is an interactive presentation,
Nah.
Tina. So you're in timeout in just a second.
Wait a minute, use your PBIS tools.
All right. So whatever you think your research problem is, you do need to take a moment and ask yourself a couple of questions. Is it really a problem? And you say that you want to study, SAT scores and the relevance or the correlation between SAT scores and students coming from a low socioeconomic background. You might really be passionate about a topic, but you need to ask yourself, is that a problem? And what makes it a problem? So in just a few moments, I'm going to ask for a volunteer. So I want you to be thinking about, let me use you for an example. Group 2 members, do you already have your research problem? And if so, let me just walk you through a protocol that, that you might want to think about using when trying to firm up your research problem. Anybody have one?
Yeah. Wow. The rates of out-migration in Eastern North Carolina and healthcare delivery over the next 10 years.
All right, so very good, Dr. Munn. So now if that is your problem, I'm gonna follow up with that and I'm gonna ask you a couple of questions. And this will give you an idea if you're on the right track or this might not be as much of a big deal as to what you think it is, okay? So very short responses because I'm running out of time, Dr. Munn, okay? So
Give all the time in the world.
So what makes what you just stated, what makes that a problem for everybody else?
Yeah, one, rural North Carolina is going to be losing tax revenue, and the people who are living in rural North Carolina are increasingly running out of options for healthcare, which makes it tougher. Even if the state didn't want to invest in or subsidize costs, then it's going to end up costing everybody more money if we don't pay attention to the issue now.
Now, very good. Is that an opinion or a fact? I'm supposing that you have supporting evidence.
Yeah, it's a fact. It's a fact.
Okay. So right now, would you be able to provide 3 to 5 resources to back up that, stating that it is a fact?
Certainly, from the Department of Health and Human Services, all the way down to the census.
Very good. And you've already answered number 2 because you've already said who's the population of people this is going to impact greatly. Okay. Yep. So why should this be addressed? And my follow-up to that, Dr. Munn, is it going to really advance anybody's knowledge, or if somebody's just going to read this and just kind of put it on the shelf?
Yeah, no, it should be addressed because, if populations continue to decline in Eastern North Carolina, then at some point, and policymakers don't take steps now, then they're going to look up and more rural hospitals are going to close. And it's going to sort of turn into a snowball effect. Once policymakers, in terms of your second question, does it contribute to practice or advanced knowledge? Yeah, the policymakers are going to certainly pay attention to the fact that in Berkeley County or Vance or Hertford County, there's no hospital within 100 miles, then they'll want to figure out how this happened and what to do about it.
Right. And actually, you also just answered the next question, because
Sorry.
that's okay. That's perfect. Because you'll want to ask yourself, then if you don't answer this question, if you don't fill in the gap and address it, what's going to be the implications? And so it sounds to me like this is something that is going to impact a lot of people if someone doesn't do the work and doesn't go down these many, many rabbit holes to try to figure out this problem. Right. So just based on that general outline, congratulations, Dr. Munn, you're on the right track. And I think that you've successfully chosen a solid research problem.
Well, thank you. And I just want to say this is an article that I'm considering writing in the next couple of weeks. So awesome. That's why I wanted to do this exercise, because it will get me thinking. But thank you. Go ahead.
Awesome. Awesome. And a lot of times when you're reading about research problems, they'll compare it to a funnel. They'll talk about how it starts really big and then it's going to narrow itself down. So next, we're going to go into a more narrow process in learning about research questions.
Thank you, Vonda. So we just learned about what goes into a research problem. And we just learned that it is the critical beginning of the study. So now we're going into formulating your research questions. So research questions are queries, questions, or inquiries about relationship between two or more variables. All right, so let's talk about the types of research questions. We have descriptive, which talks about how much or what is, comparative, whereas we're talking about the difference between the variables, and then we have relationship-based. That's describing the association or trend between the two or more variables within that one demographic group. So your research questions must include the following. The problem must be a question. The question is about the relation among the variables. The relationship is capable of empirical testing, which talks about basically the direct and indirect observation and experience. So research questions are used to do the following. They're used to shape and specifically focus on the purpose of the study, inquire about the relationships among variables that investigate and that the investigator seeks to know, and that these questions are frequently used in social science. So these questions, these types of questions the researchers may ask will help to determine the type of statistical analysis that needs to be conducted. It is also important to consider what specific variables need to be assessed when writing these research questions. So now we go to narrowing your questions. So good research questions should match the purpose for an assignment and provide an argument. It asks one to consider all the small questions and answers we find as part of a single problem. So we're focusing on a specific area of curiosity within the discipline or assignment. It's clear and precisely stated. It is not a topic, fragment, a phrase, or statement. So now we're going to look at this chart. So you're going to start out with a broad topic, such as the example up here is global warming. This is vague, so therefore we need to look at being more specific. So we want to make sure that we, to do that, we're going to generate a list of more specific areas of interest related to the overall topic. All right, so another example we have is would-be crime. All right, again, that's vague, so we need to be more specific. So when you generate your list of more specific areas, you're going to come up with your focus idea. So the example that we have on this chart is the global warming effect global warming's impact on world health. Okay, so we're going to use your focus idea to generate questions. So how do we do that? So to generate these questions, you're going to generate a list of questions that you would like to explore related to your focused idea. So the example on the chart, I'll just go over one, is what is the role of the World Health Organization in response to increasing diseases? So again, we want to go from general to more specific. So to be more specific, what climate changes are expected? What diseases are most sensitive to climate change? And what areas of the world are most at risk? So going back to the example of crime, how can this be a more specific question? Is racial profiling affecting arrest demographics? So this chart helps you understand how to break it down from a broad topic to developing and formulating your specific questions.
And as you're narrowing down the things that you are going to research, you're going to start looking at variables. And so we're going to do a quick review of variables. I will ask that if you have another device, a phone, or another laptop you're using, have it ready for an activity. We're going to do a few slides down. So what is a variable? It's a characteristic of the participants or a situation in the study, and they have to have a different value. And so when their values vary, it can be in different ways. Some examples are gender, age, or if you were looking at curriculum, a different curriculum you were using in your school. Oh, I think we moved a little too fast. So anyway, we're getting there. So experimental research studies the effect and manipulation of one of the variables on another variable. So then we're going to do our quick review in a minute on independent variables and dependent variables. So pay attention to this slide. So independent variables are the ones that are manipulated. They're the variable from which predictions are made, and then they influence the other variable. So it's the doer or the variable that's doing the doing in a study. And usually the independent variable comes before the dependent.
Oh, dang.
So then you can look at the dependent variable, and that one's the observed and measured variable, the consequence variable, and the object of research. And it's the variable that's done to in a study. So dependent variables usually come after the independent variable. And there was two different examples at the bottom about the amount of sleep. Does it affect the performance? So amount of sleep is the independent, and the performance on the test is the dependent. All right, so now we're going to do a quick Kahoot game. And so we are going to, you'll go to Kahoot. On the screen, you will see the pin that you'll need to put in. I'll just do a quick reminder, appropriate names, friends, appropriate names. That was for Gerald. I saw his face. Appropriate names. The winner of this competition will get coffee on me once we see each other again in 2022 at graduation.
We're going to close this in 5 seconds. So if you haven't gotten in, you literally have 3 seconds left at this point in time.
All right, so which is the independent variable? Cinderella is wondering if the temperature affects how fast her carriage is. All right, the correct answer was temperature. We're going to go to number 2. Well, they're going to show who's in the lead. Very good, Braveheart, with 933. Question number 2, what is the DV, the dependent variable? Elsa is testing how the time of year affects how powerful her powers are. Okay, how powerful her powers are. SpongeBob wonders if the amount of oil under the sea affects his pineapple shape. The dependent variable is pineapple shape. We're going to only do one more because of time. So this is our last one. Carly is wondering if the amount of fried chicken Sam eats affects how lazy she is. The independent variable is
They ain't no fried chicken.
they do. It's a special kind.
It's oven fried.
That's right.
Air fried.
The amount of fried chicken. So we're going to stop there. Let's see who is in the lead. Not the winner. You didn't claim it right this time. So if you wanted to continue this on your time, that is great. We're going to stop there.
You got to see the podium announcement.
Yeah, that's always
the
nice.
best part. Great job.
Who was not the winner?
I was not the winner.
Oh, good.
Yay.
Let's be more positive from now on.
That's I like that nickname. I'm going to steal it the next time I have to play Kahoot.
So we're going to move to classifying variables quickly. So there is categorical and continuous. Categorical are mutually exclusive, and you'll see examples below. And remember, those variables are only in those groups. They are mutually exclusive. Continuous is an infinite number of values within a range. So one of the questions you can ask yourself is, can this variable be more of this? So can a person be taller? That would be continuous. So generally, continuous is yes to that question, and categorical is no. So under categorical, you have nominal, which involves placing objects in mutually exclusive categories, and they do not indicate value or quantity and do not represent an order, like marital status, birthplace. And ordinal ranks objects according to how much of an attribute they possess, such as job satisfaction, condition of health, and place awarded in a race. Continuous variables are objects placed, interval variables under continuous variables are objects placed in order, and they have equal intervals between objects. And the 0 is arbitrary and does not represent an absence of the variable. For example, your IQ or your GPA.
Right.
Ratio is objects placed in order and has equal intervals between objects, and there is a true 0 like age, weight, and height. And so this is a chart that you have access to in our research and education book that will kind of help you walk through trying to decide what is a nominal, what is an ordinal, what is an interval, and what is a ratio. And so this activity, we were going to give you 2 minutes, and I believe our timekeeper is saying our time is almost up.
We have time.
We do have time. All right, so we are going to give you a chance to describe yourself using the variable. So we're going to put the link in the chat box to the Google document. And what I want you to do is use at least, put your name down, and then you're going to put at least one categorical and one continuous variable that you would fall into that group or that would describe you. And so if you'll go to that, you have 2 minutes.
Yo.
Whoa. Good morning. Next, we're going to follow up again with more levels of measurements.
Levels of measurement. These can be split into two groups, qualitative and quantitative data. They are very intuitive. So
Qualitative variables. Nominal data is labeled or named information that can be divided into various groups. Nominal data is not measured or evaluated in this case. It's just assigned to multiple groups. Nominal data is unconnected. You can have a Nissan or not. It's not a order as far as best whatever. Ordinal data is a kind of categorical data with a set order or scale to it. For example, ordinal data is said to have collected when a respondent complete a Likert type scale. The responder simply inputs his opinion on a scale 1 to 10. In ordinal data, there is no standard scale on which the difference in each score is measured. You strongly agree, you disagree, you strongly disagree. Qualitative variables are interval data, also called integers, and is defined as a data type which is measured along a scale, in which each point is placed at equal distance from one another. Interval data also appears in the form of numbers or numerical values where the distance between the 2 points is standardized and equal. Examples are your temperature in degrees and Fahrenheit, IQ tests, intelligence scales, those type of things. Ratio data is defined as quantitative data having the same properties as interval data with an equal and definitive ratio between each data, and absolute zero being treated as a point of origin. Your height, your weight, your age, how much money you have. Those things can be added and manipulated in those areas. Next, we'll have hypotheses.
Gerald, I do see your question, and you asked, can a variable be converted to the other type of variable? So for example, continuous to categorical or categorical to continuous. You can do this. It would have to meet the need of your specific, what you're doing with your data. So for example, for a very quick example, in one of our previous assignments in quantitative, there was a grouping that you were able to be 1, 2, 3, 4, 5, 6, 7, 8, or 9. It was kind of along that variable, but we wanted to break those off into categorical variables. So were they in this grouping of variables, for lack of a better word, or were they in this grouping of data? So we were able to manipulate that to drill down a little bit more. So you can do that, but you don't want to just do it by happenstance. You want to really know why and have a reason as to why you are doing that conversion of variables.
And you can even turn that into a dichotomous variable by just saying less than 5, more than 5, and you have 2. And
Which is exactly what we did.
Mm-hmm.
Yep.
Good morning, everyone. Oh, okay.
No,
Good morning.
I'm passing it to you.
Okay.
Good morning,
you,
Ms. Simons. You know I'm pick at you, right?
So you all, so far you've heard a lot of information, and I think now you're at the point where you're ready to state your hypothesis.
Mm-hmm.
And so EDLE defines a hypothesis as basically a statement describing the relationships among variables. And you've already heard what a variable is, and a variable that is tentatively assumed to be true. So there's 2 reasons in a quantitative study that the author says that. Oh, okay, I'm sorry. Did somebody say something?
Sorry, I was reading. No, go ahead.
Okay, no problem, Gerald. Okay, so the author talks about 2 reasons of stating a hypothesis in a quantitative study. Number 1, a well-grounded hypothesis indicates that the researcher has sufficient knowledge in the area to undertake the investigation. And then number 2, the hypothesis gives direction. So remember that the hypothesis gives you direction to the collection and interpretation of the data. It tells the researcher what procedures to follow and what type of data to gather, and thus may prevent a greater deal of waste time, because we know we're trying to get out in 3 years, so we don't have time to waste. So to waste time and efforts on the part of the researcher. 2 types of hypothesis, inductive and deductive. And induction and deduction are complementary processes. And this, when you're looking at an inductive hypothesis, it begins with specific observation, then reaches a general conclusion. For example, after-school tutoring programs increase the achievement of at-risk students. A deductive begins with generalization, then makes specific predictions. So this is very general. When it rains, Shannon's old car will not start. It's raining, therefore Shannon's old car will not start. So if you can see the difference in the 2, in inductive and deductive. Again, inductive starts with specific observation. Deductive is more of a generalization. Hypothesis states the expected relationship between variables. And again, you've already heard what a variable is. And a hypothesis should conjecture or guess the relationship between a study's variables. So for example, you attempt to start your car, but you observe that nothing happens. So you can't not say that the car will not start and it has a wiring system. So you try to start the car, but you can't, your hypothesis can't be the car will not start and it has a wiring system. However, a better hypothesis would be that the car will not start because of a faulty wiring system. And remember these 3 things when you're writing your hypothesis. You must be concise and declare a statement and have a declarative statement. Should clearly state what the researcher needs to do to test it. and avoid ambiguous or vague constructs, and use terms that are generally accepted when referring to the studied phenomenon. So remember these three things. So now we get to types of hypotheses: research, null, and alternate. So in research, that states the relationship one expects to find as a result of the research. It may be a statement about an expected relationship or the expected differences between the variables in a study. So we have directional versus non-directional. So directional, it states the direction, exactly what it says. For example, there is a positive relationship between IQ and anxiety in elementary school children. So the direction is that it's saying that there's a positive relationship. Non-directional hypothesis states that a relationship or difference exists, but does not specify the direction. For example, there is a relationship between IQ and anxiety in children. So if you look at the difference in the two, the directional says it gives you the direction that it's a positive. Non-directional just basically gives you the relationship. It's saying that there is a relationship between IQ and anxiety in children, but it doesn't give you the direction in which it would go.
All right, excellent job.
Go ahead, I'm sorry, Maurice, go ahead.
No, go ahead.
Okay, all right, that was my name. Okay, thank you. So the next slide is null. And these are the two, null and alternate, or what we have just talked about last week and what our homework was in reference to. So when you talk about null hypothesis, and it gives you the symbol, a null hypothesis is a general statement that there is no relationship or association between two phenomenons. So for example, there's no difference in mastery of mathematical concepts between students taught through individual instruction than students taught through group instruction. Again, there's no relationship.
Uh-oh, I think she paused. Well, until she comes back, you can see on the screen where the additional one is the alternative or alternate hypothesis, which describes, oh, go ahead, Cynthia, there you are.
Okay, I'm sorry, my computer froze. I'm so sorry, I was just talking away. But thank you for picking that up for me, Maurice. Where did you end up?
Right where you left, at alternate hypothesis.
Okay, so an alternate hypothesis describes that there is a relationship between the variables of study. And you have your symbols there. So for example, children taught by individual instruction will exhibit less mastery of mathematical concepts than those taught by group instruction. And then just closing, I wanted to have a little funny, and hopefully no one is offended by this. So as we go into Maurice's next part, because I think I'm finished, I'll leave this joke with you, and you just find the answer on your own. Why does no one date the null hypothesis? Go ahead, Maurice.
All right, thank you, Cynthia. So we've really done a robust review of really the foundations of statistics, really moving from theory all the way to what Cynthia just finished off with, which was hypotheses. In time and space, we're gonna skip some months or maybe a year because, you know, what has happened is you've determined your theory, you have your framework, you've gone through your research problems and your questions, you've gotten everything in, your hypothesis is right, and now you've gone through IRB approval and you went and you collected some data. And what we're going to do is really very quickly give you kind of these first things that you really could do with your data to begin to show what's going on in your study. So when we talk about measures of central tendency, in layman's terms, in the most layman's terms, what we're trying to figure out is what is the tendency for the data to be clustered toward the center. The center is kind of the hot spot, it's where we want to be, and it really has the ability to tell us a lot from the data that we have collected. So I like to call these the 3 M's. Very easy to remember. measures of central tendency really are those 3 M's. We talk about the mean, and what that is, what is the average of the data? Of course, we all know how to find the average of the data. We add up all the data, we divide it by the number of occurrences. That gives us the average of that data. Then we talk about the mean as well, the second M. What's the middle of the data? This really helps us to kind of look at if we were to look at like a number scale, it really helps us to figure out, okay, well, what's right there in the middle of that data, and that begins to help us shape what's going on with our collected data as well. And then the mode is what is the most frequent response of the data, which really could help you into determining, okay, how many people answered this question the most. Okay, so what does that mean? What is that starting to tell us about our data? The measures of central tendency really begin to show broad pictures as it relates to our data. Now, while the measures of central tendency typically are those mean, median, and mode, we've got a couple of honorable mentions, which are minimum and maximum. As you can see here, the minimum is what was the lowest score or whatever the lowest data point was. In this example here, you have 2 is the minimum, and then 8 is what is the highest. So the maximum, and here you have 8. So you say, well, why are they honorable mentions? Well, minimum and maximum are really important, or really can be important, because those values can help us draw greater, they help us to provide greater context for the measures of central tendency. So for example, we already had that data, but let's say that we extended this and there was another piece of data and the maximum became 20. I want to pose the question to group number 2. If we had a data point of 20, how does that new maximum, quote, misrepresent the data?
It would skew the data because that would be an extreme outlier.
Exactly. So I'd done the math, and I may or may not remember, but in appropriate, or rather in approximate terms, the average of the original data here was right around 3 or something. It was 3, somewhere between 3 and 4. Now, what happens is if you place a maximum value of 20 within that data set, it does exactly as Brady says. It skews that data and it pulls the average or the mean of that data way further up, which misrepresents the data because that's not really the average, because you have this extreme outlier. So that's why it's really good to look at minimum and maximum in addition to those the mean, median, and mode, because it helps you to paint a greater and more in-depth picture of your data. So our final thing that we're going to do is just a very quick activity to help you understand when you start to move into, you've got your data, you're in SPSS or whatever your given platform is to manipulate and analyze data. I want you to think about what are the types of variables required to successfully run a test in SPSS. So we've talked about nominal, we've talked about categorical, we've talked about ordinal, and we've talked about ratio. And now we're talking about, okay, we want to find the mean, we want to find the mode, we want to find the median. How can we begin to run tests that will give us what we need in order to make inferences about that data? So what I want you to do is using the annotate feature in Zoom. On the next slide, you're going to get a grid. I want you to place a yes for a Y, excuse me, for yes, and an N for no in the appropriate spaces on the slide. And what we're trying to figure out essentially is when you look at this, this grid, can you find the mode of a nominal value? Or a nominal variable, excuse me. And you would want to say yes or no. Or for example, can you find the median of the interval data. And not just can you find it, but will it be true actual data that you can use? So again, using the annotate feature, you're able to hover over your Zoom toolbar. It will say annotate. If you click on that, you can either type in an N or you can click on draw and just draw a Y or a yes. We're not going to take a lot of time with this, just maybe 30 to 45 seconds. And again, I'm asking you to do a Y or a N. Rather not DKs, thank you. Y'all are like those students who just won't listen. Again, this is for your
I'm
benefit.
hovering and I don't see any annotate. Nothing's coming up. So tell me, I'm hovering all along the bar. Where am I? What am I doing wrong, Maurice?
If you see, and you may not have it, and sometimes the devices run different.
Can you hit view options up there at the top?
Oh, okay. Thank you.
Thank you.
Oh, I see it. It's in view options. All right.
And we're just going to take just a couple of more minutes, or excuse me, just a couple more seconds with this. It really just helps you to get to figure out what you can and cannot do to run a successful test in SPSS as it relates to the measures of central tendency. All right, y'all have done a pretty good job. We see some yeses, some other yeses over there. So now let's talk about what the answers are. So these are the answers here. This is a really good snapshot. If you have not written this down in your notes in previous classes, I would suggest that you take a very quick snapshot, because this begins to tell you what tests can be run as it relates to the variables that you have. That's very important when you get to analyzing your data, because, for example, if you have a nominal variable, you have male or female, 0 or 1. And you say, well, I want to know what the mean, I want to know what the average is of that variable. Well, you can run that, but you're going to get a number that isn't 1 or 0, because you're going to get somewhere in the middle of that. And that's not going to tell you what the average number of males and or females was. So SPSS may let you run the test, but it's not going to give you anything that is usable. So it's very important as you get towards running tests that you understand, as the group has really done a good job of laying out nominal, ordinal, interval, and ratio values, that you understand what tests you can run so that you can get usable data. And just as a very quick wrap up, the theory drives your research problems or your research questions. Your hypothesis then sets the stage for your study, with levels of measurements or your variables determining how you shape your study. And then finally, the measures of central tendency begin to help you show your data in very meaningful ways. And once you get through that, then you begin to go into some more robust and more complex data analytics, which include measures of dispersion, crosstabs, chi-square, and all the other ones that group number 2 is going to go into. We want to make sure that we show you our references right there. And we have about 7 seconds for any last minute questions. I see none in the chat.
I have one.
Yes, ma'am, Ms. Thomas.
Your fantastic presentation. As I'm going through dissertation-wise, what point in that dissertation would you say that your presentation covered out of the parts?
That's very good. So we are, our presentation, and of course anybody in the group can jump in, but we're really at the beginning, the very beginning stages. who was it? Terrence did a wonderful job of, you literally start with the topic. What might I want to cover? And really from there, you begin to say, okay, well, what framework can be used to explore that topic? And then when we get to the framework and we get to the variables that we can use and the hypotheses, it's really the beginning, even before you get to determining what you're going to do for your for your dissertation. Our presentation helps you to begin the thoughts of what your dissertation is going to be and how to move forward in the beginning stages of figuring out how to frame your dissertation.
If I could just also add to that too, Cheryl, that the part that Vonda talked about, your problem. What is your problem, and would your problem impact others? And is it worth writing about? Is anybody going to be interested in hearing what you have to say? So I know that part definitely helped me out this morning.
I have a question as well. Just because I'm looking at a mixed methods and I'm trying to decide, and I'm not sure how to frame this question, but when you are looking at a dissertation topic and deciding your problem, I guess I'm trying to wrap my head around, how do you decide what to do quantitatively and what to do qualitatively? I don't know if I'm wording this correctly, but when you think about your hypothesis, how do you pick which? So let me give you an example. I'm looking at trying to look at the effective or ineffective impact of day treatment programs on students with behavior issues in the elementary level. And there's one operating right now in Cumberland County in an elementary school. But I also want to look at the other day treatment programs that are operating around the state of North Carolina as well by the same company. So I guess I'm trying to figure out, how do I decide what to look at qualitatively through interviews and the qualitative side, and what data to do quantitatively. And I don't know if maybe Vonda could, how do you narrow that down, I guess? Maybe, and I don't know if this is appropriate for your presentation, but that's just what I was thinking about. You're muted, Vonda.
And I'll jump in really quickly. And then
I don't even know if that's an
appropriate. How are you going to measure if the program is working? Are you measuring it by how many students come out of the program? Like,
well, that's what I'm asking. Like, how do you decide how much of that is quantitatively examined through looking at the
there are certain things that are set really that you can do quantitatively or qualitatively in terms of your data collection. So it seems like you're talking about data collection. Where does that fall?
Yeah, I'm trying to narrow it.
Yeah, so there are certain things that give you quantifiable data, such as questionnaires, scales, surveys, typically will give you quantifiable data. Whereas if you're looking at more subjective things, people's perspectives, observable things, those may tend to be more qualitative. But the books do a really good job of helping you to understand, if you're looking at quantitative design, these are really the groupings of data collection measures that you can take, and vice versa with qualitative.
I'm not a master on mixed methods, but there's explanatory and exploratory mixed methods. And I think what you're trying to figure out is which goes first. And I think in this situation, whenever I think of mixed methods, I think about if I'm going to do quantitative first to sort of, and that's sort of explanatory, what I would be doing is running quantitative analysis or a survey, and those numbers or the output is going to tell me where then I need to go and ask questions and get more contextual stuff from. if I'm doing exploratory, where qualitative is first, then I ask questions in a couple of schools or in places where I do interviews or whatever kind of qualitative design I'm going to use, and then that tells me where then do I need to go do my collect data for my quantitative analysis.
That's
So,
helpful. And
yeah.
and I didn't
Sorry,
mean
Tanya,
to
I
put
did
you
not
on-
grab that from your question. I'm sorry.
No, I didn't even know for sure how to if it was an appropriate question for your team, because you laid out the whole process. I guess I was just trying to think through in my head, and now I'm thinking maybe it needs to be a quantitative project more than a I'm not sure, but anyway, I appreciate
Just
it.
as Dr. Munn said, now the Creswell book does a phenomenal job of telling you, especially as it relates to mixed methods, like if you want to do this and then do this, this is how you would go. So it really goes into that explanatory versus, was it exploratory?
Exploratory.
Yeah, so that the
I'll
Creswell
go back and
book,
review that in Cresswell.
yeah, and it was the first one. It was from fall 19. I specifically remember that.
Okay, thank you. You guys did an awesome job. I liked all the little interactive stuff.
Thank y'all so much for your for your time, and thank you, Dr. Munn, for our extra 20 minutes that you gave us.
Oh no, that's a great book. Tina's showing you the book. That's a great book. Who assigned you that book?
Dr. Williams.
That's a great book. Yeah, that's a great book. No,
Seems like forever ago.
yeah, no, for sure. No, that was incredible job. I'm not just saying that. It was very, 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 very good. I love the interaction. That's very, very, very important. Well, I don't mean to cut short the accolades, but let's go straight into group 2, so we can get through as much as we can today. And yeah, that was great. I sincerely appreciate the work that you did there, and I hope it was helpful, sort of, for each of you to sort of refresh, and embed this into your minds. It's always good
a
to.
restroom break. Can we get a quick restroom break?
Sure. Let's do 5 minutes. Come back
minutes?
at 31.
Okay.
Yeah.
Can we get a copy of that presentation? Group 2, anyway.
Already.
That was good stuff.
We'll send you the PDF version of that.
It doesn't matter whether it's PDF.
Yeah, no, we'll send it.
Appreciate it. That's nice.
Yeah.
Question, can y'all still see me?
Yes.
Okay, good. I have to remember that.
See, none of y'all really, I think maybe Tanya answered my question in our group meet. Y'all think we gonna go back to campus next semester?
I don't think so.
You don't think so, Fred?
Probably not.
We
I
may
wish
start
we
off
would.
that way, but I don't know if we'll finish. I think they will try it.
I
But
think we would need to figure out who our instructors are, because they would really determine what that's gonna look like.
But how are things
Dr.
down
Munn,
in
can
the
you hear me
Fayetteville area?
next semester?
I'm here. What'd you
Fayetteville's a
say?
mess right now, Fred? You just asked how it's going in Fayetteville. It's pretty
Yeah,
bad.
is
Yeah.
it? So that's why I don't.
You said it's pretty bad, Brady?
Yes.
Yeah, we're a red zone.
Oh,
Yes.
wow.
Our schools haven't opened yet, but even the teachers, we're having to close schools for the teachers even. I mean, it's just, it's not good.
Dr. Munn, are you teaching next semester?
I'm not sure. I don't know. To your point about the virus, yeah, I don't see it getting getting better. People are going to socialize. We have a lot of highly social events. So people are going to do Thanksgiving. People are going to do Christmas. As long as we have these major holidays, people are going to. I mean, the spike after Labor Day was so predictable. You know, I could have put money on it, and so that we're where we are is right now is not surprising at all. I guess I would expect more of our institutions to prepare us for this, but yeah, I don't see us. I see them trying, and see, I think that's what exacerbates things now is the fact that we try these things and then we just spread it all over again. And it's not effective. Like, you've got to shut down like completely for 3 months. Everyone has to wear a mask. You don't wear a mask, you know, you're held accountable. And then once we do that, then it's over. But, you know, until we actually do that consistently all over the country, it's going to keep having these hot spots. And not to mention places that have meat packing plants. Look at the counties in North Carolina that have meat packing plants or in the vicinity of meat packing plants. And you're going to see per 100,000 numbers that are off the chart. Don't look at the cases, you know, the number of cases. That doesn't tell you anything because Wake County and Mecklenburg are always going to have the most cases. Look at the cases per 100,000. And when you see that, it's crazy. It's crazy.
Now, and I'm not complaining because I don't mind jumping right on the Zoom rather than driving to Fayetteville.
I do think
that drive up the hallway was terrible this morning.
I don't even know how we used to do that on Thursday nights coming home. Like, that was crazy.
I do think that as students, you all have, you know, incredible input into what it is that you want to do. So I would come together as a cohort and talk about what you want your reality to be for next week.
They don't care nothing about that. We tried to voice our opinion. They don't care nothing about that.
They make it seem like we're teenagers in high school and
Oh no,
making this stuff up.
Listen. But I got a whole list of stuff that I'm gonna give on some evaluations.
Okay, said it. We're gonna save it for the survey.
I'm looking to evaluate the program. I'm good.
All righty. It is 10:31. I'm excited to get into measures of dispersion and all the other goody stuff. So team number 1, incredible job again. Tee up your questions. All right, let's fire it up. I think who's going to be the leader for group number 2?
I will start us off.
All right, let's do it.
All right.
Let's fire up that SPSS.
All right.
All right.
Okay.
Go ahead, Ms.
Miss Sharon, gonna pull that up.
Mr. Gerald, can you drop the data set in the chat box for them, please?
You're muted, Gerald.
Yes, I'll put the correct link. Let me go ahead and get it real quick.
Brady, are you pulling up the presentation?
I thought Tina was our screen share. I can do it.
My mistake.
That was my job. I apologize.
Yes.
Okay.
What class does this data set come from? Does it come from statistics?
PK-12.
Yes, it's from Kanuka's class.
Okay, I just want to know.
K-12-2.
What's the homework?
Okay, may I be allowed to share the screen now, guys?
Yeah, it should allow you to do it. Is it allowing you to do it?
Yes.
Nice.
Okay, now I'm not able to see the chat box or you guys, but are you able to see my screen?
Yes.
Yes.
Okay.
Okay, and good morning, everyone. Group 2, consisting of Philip Boyu, Brady Davis, Gerald Hernandez, Tanya Higgins, Tina Mitchell, and myself, Cheryl Thomas. We will be talking about measures of dispersion, crosstabs, and chi-square. We're first going to go into measures of dispersion, which is to find out the spread of your data values. This is the analysis or way that you can analyze your data. We took a scenario or created a scenario using a PK through 12 data set. Our scenario that we created was William H. Munn Elementary has collected achievement data for their students in both reading and math. The principal, Dr. Corona, asked for suggestions to disaggregate the data and look for trends. The fifth grade team insisted that their male students had no interest in reading, and therefore the female students consistently passed the reading test at a higher rate. The fifth grade team proposed a sizable purchase of nonfiction and male-targeted reading materials for their media center to address the disparity among the genders' reading scores. Dr. Chitiga agreed to approve the purchase if they could prove their hypothesis using the data.
Sorry, that second one should be Dr. Corona again. I'm sorry.
No problem. So we first want to go into the measures of dispersion, which is going to lead to the spread out of your data values. What this is going to do is help you to interpret the variability of data. It's going to show whether it's homogeneous or heterogeneous, okay? And it's also going to show the squeeze or the scattered, how squeezed or how scattered the variable is. We're going to talk about characteristics of a good measure of dispersion. It should use all the scores in the distribution. It should describe the average deviation of the scores. It should increase in value as the distribution of scores increase in variety. It should be easily calculated and interpreted. When we talk about measures of dispersion, even though there's more than the three that we're going to talk about, such as one that was brought up in group one, range, the difference between maximum and minimum values, we're also going to go into the interquartile range, which is it narrows down that difference. It kind of pinpoints where most of your values lie. To me, being in education, that would really lend into when you're finding, let's say, about those reading scores. Would there be a program that would specifically target not only male, female, but maybe if the male, female had some type of disability, would a program that could be offered, let's say such as MobiMax, would be beneficial to a specified group? You would be able to tell that using that interquartile range because it's going to be more specific. Okay, we're also going to talk about variance, and we're also going to talk about the most common of the measures of dispersion, which is standard deviation. Your variance is going to measure how far a set of numbers is spread out from your average value. Here again, your standard deviation is your measurement of the amount of variation of a set of values. Your interquartile range, again, is going to equal to the difference, not between the minimum and the maximum, but it's going to break it down between that 75th and 25th quartile.
All right, thank you, Ms. Thomas. Before I pick up the second part here, if you have not downloaded the data set and got that pulled up on your computer yet in SPSS, please take a minute to do so as I'm talking right now. So you will have it prepared when we get to that shortly. Right now, I'm going to pick up with variance. Now, variance is the average squared difference of the values from the mean, and that includes all the values in the calculation by comparing each value to that mean. Now, I have two questions for our group 1 members right now. Look at the formula that is there on your screen. We have two types of variance. We have sample and we have population. So if somebody could type in the chat there, does that formula show you how to find the sample or the population, and why do you say that? So let's see if we remember. So I'll just give you a minute to respond. So the formula, is that for a sample or population, and how do you know? We know what Maurice is thinking. What's somebody else thinking? All right, so if you look at the bottom part there, it'll kind of tie back into the question. It says it is generally impossible to measure an entire population, so statisticians usually focus on sample variance. The example you have above is for the sample variance. It's the n-1. Now, if you ask me to say why exactly is it n-1, I don't know for sure, but the formula for the entire population would be n. But basically, we hardly ever use the entire population because it's almost impossible to get the entire population at one time. So we only use a sample group of that population. That's why it's the n-1 part there. Maurice asked the question, why do we need to know the variance? The variance is just another way to look at the data. It just helps you to know, are most of the answers going to be fairly close to the same, or the answer is wildly different and everything else. The variance, the number itself, in my opinion, the number doesn't tell you much. So I guess Dr. Munn could give a more specific answer to that part, or someone else in my group, but the variance itself, to me, is not as meaningful as a standard deviation, so.
That's absolutely right. And I'll say as well, when you look at the n in the bottom of that equation, is it capitalized or is it lowercase?
Capital.
So when you see it capitalized, that represents the entire population. When it's lowercase, it represents the sample.
Okay.
Yeah.
That's what I was gonna say.
Mm-hmm.
Thanks for having my back, Tina.
I had
Right, next.
But yeah, that explanation is absolutely right. It is not a very useful, tool, but it is there, and it is one step, gets you one step closer, gets you one step away from standard deviation. So, which is very useful.
Next slide. Okay. Now, just like we just said here, we have population and sample, and I got ahead of myself a little bit, but population is every single member, or all members of a specified group. Sample is just the part you are using for your specific study, or the part of the population that we are then applying theory to the rest of the group using. Next. Okay, interquartile range, as was introduced earlier, is slightly different from just range itself. It's the middle half of the data, and it's equivalent between the 25th and the 75th percentile. And this does come in handy when the data is slightly skewed. It can be a little more meaningful than just the range itself. So the next slide will show a representation of that. directions to find that first of all. So you can divide the data into 4 different parts, and then the values that divide each part are the first, second, and third quartiles. Q1 is the middle value in the first half of the rank ordered set. Q2 is the median. Q3 is the middle value of the second half. So picture the middle, you've got the half in front, the half after that. Q3 minus Q1 gets you the interquartile range. Next. And here's just a short video. If you would just press play, you don't have to interact with this part. We're just going to show you this little video clip here.
In this video, I'm going to show you how to calculate the interquartile range of a dataset in SPSS. So in SPSS, I have a list of participant ages, and I want to know the interquartile range for this dataset. So to calculate the interquartile range in SPSS, you go to Analyze, Descriptive Statistics, and then Export. And then what you want to do is to place your variable of interest in the dependent list box, and then press the OK button. And then the output window should open, and within the table of descriptives, you'll find the interquartile range listed. So this is the difference between the third and the first quartile of that data. So if you want to find out what the first and third quartiles are, you go to Analyze, Descriptive Statistics, and then Frequencies. And then you want to drag over the variable that you're interested in into the variables box, and then click the statistics button. And then where it says percentile values, you want to click the quartiles option, and then click the continue button. Finally, click the OK button. And in the output, what you'll then see are, under the statistics table, the percentiles. So the 25th percentile is the first quartile, and the 75th percentile is the third quartile. So that's how you can find out the first and third quartiles. So in this video, I've shown you how to calculate the interquartile range, find the first and third quartiles for a data set.
All right, thank you. Next slide. Okay, and these are just a couple graphic representations of interquartile. The one on the right side, who can tell me what that one is called?
Box plot.
Box plot, thank you. And actually, I hadn't thought about a box plot for years until I had this class, but it gave me flashbacks. When I used to teach 4th grade math even, we used to go over this with our 4th graders. I believe it's now a middle school standard. Can any middle school people, is that true? Do we do this in middle school now? I see Miss Thomas shaking her head, yes. So
8th grade.
8th grade, got you. So when I taught 4th grade, it was box and whisker, you know, because it has little whiskers that are sticking out. So it just gave me flashbacks. But yes, that is a box and whisker plot. If you notice the one on the left, that is our, what is that called?
Normal distribution curve.
Ooh, look at you. That's the AIG answer right there. Yes, that would be the normal curve. We've got the median directly in the middle. And then if you notice, it kind of follows the rules that it should. So thus he called it a normal distribution curve. We've got our 25%, so on and so on. Has the formula there for the Q3 minus Q1 to get your final interquartile range. So next. All right, our third thing we're going to talk about is standard deviation. So go ahead and press play, and then we'll work with SPSS with some stuff in a second. Go ahead.
Have we discovered a new particle in physics? Is the manufacturing process out of control? What percentage of men are taller than LeBron James? How about taller than Yao Ming? All of these questions can be answered using the concept of standard deviation. For any set of data, the mean and standard deviation can be calculated. For example, 5 people may have the following amounts of money in their wallets: $21, $50, $62, $85, and $90. The mean is $61.60, and the standard deviation is $28.01. How much does the data vary from the average? Standard deviation is a measure of spread, that is, how spread out a set of data is. A low standard deviation tells us that the data is closely clustered around the mean, or average, while a high standard deviation indicates that the data is dispersed over a wider range of values. Standard deviation is used when the distribution of data is approximately normal, resembling a bell curve. Standard deviation is commonly used to understand whether a specific data point is standard and expected or unusual and unexpected. Standard deviation is represented by the lowercase Greek letter sigma. A data point's distance from the mean can be measured by the number of standard deviations that it is above or below the mean. A data point that is beyond a certain number of standard deviations from the mean represents an outcome that is significantly above or below the average. This can be used to determine whether a result is statistically significant or part of expected variation, such as whether a bottle with an extra ounce of soda is to be expected or warrants further investigation into the production line. The 68, 95, 99.7 rule tells us that about 68% of the data fall within one standard deviation of the mean. About 95% of data fall within two standard deviations of the mean, and about 99.7% of data fall within three standard deviations of the mean. The average height of an American adult male is 5'10", with a standard deviation of 3 inches. Using the 68, 95, 99.7 rule, this means that 68% of American men are 5'10", plus or minus 3 inches. 95% of American men are 5'10", plus or minus 6 inches, and 99.7% of American men are 5'10", plus or minus 9 inches. So this means only about 0.3% of American men deviate more than 9 inches from the average, with 0.15% taller than 6'7" and 0.15% shorter than 5'1". This reasoning suggests that LeBron James is 1 in 2,500 and Yao Ming is 1 in 450 million. In particle physics, scientists have what are called 5 sigma.
Go ahead and stop the video now.
Results that are 5 standard deviations above or below them.
All right, thank you very much. So at this time, if you all have the SPSS pulled up, I'm just going to walk you through some steps. We go back to that slide. All right, so when we are looking right now, we are just looking for our normal curve. That's what we just want to find to represent what we just saw in the video, standard deviations. If you have the well, any data set really, but we'll be using the same data set later. So if you have the K-12-2 data set pulled up, you have your directions right there on the screen. We've got the picture over there for how to make sure you get the histogram with the normal curve. So this is one way you can get there. So if you just start off on analyze, descriptive, frequencies. Now on step 4, you can pick any of your own interval variable. You don't have to just use the reading DDS score. That is what we use, but just select one of those. Charts, histograms, show normal curve. So I'll give you all a minute to create one of those yourselves. Any questions about those steps? And if you were just able to represent your data with the bell curve, if you just type "got it" in the comment box, we'll know that you were able to make one yourselves. All right, next slide. Go ahead and go to the next slide. All right, so this is what the curve I came up with using the reading DDS score, and it's fairly normal. What do you guys notice on this curve? How would you describe it? Anything you see that sticks out particular?
I would describe it as normal, just knowing that there is one piece of one score that is slightly higher within that interquartile range.
Very fair answer. What do you see on the left and right sides? What does anyone else see there?
You have some outliers, some small ones on the left side.
Yes, so there are some more outliers on the left than you have on the right. Anything else really? So that data is kind of fairly distributed. Does anyone have any comments on anything that they just ran themselves? Did you come up with a normal bell curve or did you come up with something else?
I did the same one you did, so.
All right, for time's sake, we'll go ahead and move on along.
Hold on one second, Brady. Just in case they didn't know or was able to see, we don't want to, belittle them, but when we look over here, our mean is 347 and 43 hundredths. Our standard deviation is equal to 9 and 85 hundredths. And of course, N, as we spoke earlier, is our population, which is 1,700.
All right. And I just wanted to show you these two examples here. If you look up at the top, like Tina just said, the standard deviation, you can tell the difference in the curve based off the difference in standard deviation. So when the standard deviation is 5, that means our data is close together. When the standard deviation is 15, our data is far apart. So obviously those bell curves look wildly different. And that's just how you can tell, is the data bunched together or is it far apart? All right, next slide.
Good morning. Good morning. This next part of the presentation is on cross-tabulation, or as we call it in the statistical streets, crosstabs. We're going to show you a short video to whet your palate as we serve you, and me and Tina, the crosstabs guru, serve you this digestible bit of information on cross-tabulation.
Philip, can I pause you for a second? There's a question in the chat from Terrence. Question, are there any advantages to using the box plot over the normal distribution curve when talking about interquartile range? Brady or...
Well, Tanya, I thought you were going to answer it. You read it out loud. You got so excited.
Well, because I noticed that Maurice had a question earlier that we hadn't responded to, and I know they monitored their chat box throughout, so I was trying to give the same, because I know Dr. Munn is looking for questions.
Let me see. Are there any advantages?
Data, Terrence, it's a matter of the preference in the box plot. When we looked at it earlier, it didn't break down the data as much as when you look at it in terms of the bell curve or the normal distribution curve. You were able to see which ones were truly the outliers based on the value of the testing versus when we were just looking at tails in the box plot.
And I just think back to some of the assignments we had to do in Kanuka's class. Sometimes in those box plots, you would look at them, you'd be like, I can't really tell anything from this. So the bell curve is maybe not the technical answer, but it's easier to look at, like Tina just said, to get something from it.
Maurice's question earlier is, in layman's terms, why do we need to know the variance?
We answered that one.
Gotcha. Done. All right. Thank you, Philip. Sorry for interrupting.
No, it's all good. So we'll play the video, the short portion of it. Fire away, please.
Have you ever taken a survey that asks you to check all that apply? Some people may check one response, or none, or all of the responses. Now, that may be an interesting way to ask a question, but it can be a nightmare if you do not know how to handle that kind of data in IBM SPSS statistics software. We are going to dive deeper into how to handle multiple response items in SPSS. When you use a survey item that asks respondents to check all that apply, you will use the multiple response option in IBM SPSS statistics to analyze that item. Sometimes researchers ask questions in which the respondent may choose one item from a list or multiple items, or none of the items. If I ask you what type of pets you own, you may have dogs but no cats, you may have fish but no birds, you may have a single bird, you may have a fish tank plus a few dogs, or you may have none of these pets. Multiple response items are often combined with a single item that asks people for their most important response, and then presents them with the same list and asks them to check all of the responses that apply for them. I am going to show you how to cross-tabulate a multiple response item with another item to drill down into the data to discover more meaningful findings. For this example, we will use the Clean River Multi.sav dataset. This is fictitious data about how people use a river. And I designed these data to illustrate this multiple response example, hence the word multi in the title. We will use 3 questions. Why are our local waters most important to you? We're looking for only one response here. Followed by, which of these are important to you? Check all that apply, giving people the opportunity for multiple responses. And finally, I would like to receive more information about the Passagassawakig Watershed Alliance. Yes or no? This will be the item that we will use later for cross-tabulation. The Passagassawakig is a river in Maine, USA. And the Passagassawakig Watershed Alliance is a fictitious organization dedicated to protecting the watershed into the river. They raise money each year at the Passagassawakig Bean Boil and Music Festival. Years ago, I was roommates with a former Passagassawakig cabbage contest eating winner. But I digress. First, let's get a look at our data. In variable view, we can see that people were asked if this factor was important, and the responses are coded as 1 equals yes, 0 equals no. Remember that 1 is the value that will count. The most import variable lists all of the possible responses, and the send info variable is also coded as 1 equals yes, 0 equals no. Let's examine the item about the most important reason. Go to Analyze, Descriptive Statistics, Frequencies. We just need a simple frequency table. Move the variable most import into the variables box, along with the send info variable, and click OK. We see that 32.5% of people asked to receive more information about the alliance. We can see how many people selected each of these options as the single most important feature. But we have lost all of the information about the second and third and fourth most important features. Some of the lesser important factors may still be important, however. Well, now that we have a clearer picture of our data, we will create a variable set. Go to Analyze, Multiple Response, Define Variable Set. Here, we will tell SPSS which items need to be combined for our multiple response set. We will move all of these variables from the Check All That Apply item into the Variables in Set box. The variables are dichotomies, yes or no, with a counted value of 1, because 1 equals yes. If they answered no, that was coded as a 0, and it will not be counted toward our accumulated values. So what is this categories option? We would use the categories option if we had an ordinal set of response options that we wanted to count a range of the responses as a single type of response.
We're going to stop right there because we're going to walk you through the SPSS process, and our variable set that we're using today, it's already grouped together. So we're going to show you how to separate it.
All right. cross-tabulation is a method to quantitatively analyze the relationship between multiple variables, also known as contingency tables. Crosstabs groups variables to understand the correlation between different variables. It shows that correlations change from one variable to another. It's usually performed on categorical data or data that can be divided into mutually exclusive groups. Next slide.
Okay, so everyone should have the SPSS data set fired up. So now we're gonna start with the steps to transforming data. In our set, we're gonna see where we have some data that is grouped together and we're going to separate it for this class purpose. So in order to transform data, these are the steps that you have to do. Step 1, you're going to click transform. Once you click transform, you're going to see compute variable. Click compute variable. Then we're going to rename our set. And your screen should look something like this. In our target variable, we're going to you can rename it what you like, but we chose male because we've already been given the information for the female, and we've been given the information here for the sex, but we're going to separate it today to see the difference between the groups. So for those of you who have the same data set that we are using and using the reading DDS data, you can put your target variable right here, which is male. Next, you will click female under your list that was given here, and you will hit the arrow to move female over here under your numeric expression. And then you will click OK. I'm unable to see you guys, but if everybody's ready to move on to the next step, give my people a thumbs up and we can go on.
Right, and remember, if you're still at the beginning stages of crosstabs, you want to click Analyze Descriptive Statistics to go to the crosstabs.
Tina, all we're doing is saying that male is equal to female?
No, we're going to separate the data, Maurice. So it's already, let's just say we had a sample population of male and female students. We're going to separate our male from our female.
Okay.
So Tina, our male should still be up under target variable and our female should be up under numeric expression, correct?
You got it, Fred.
Okay, I need for you to teach me this later on too, but go for it.
That's right. And so we can share our PowerPoint with you, Fred, and bam, step 1, transform. Step 2, compute variable. Step 3, we renaming it. But yes, we can do that, Fred. So I'm going to move on to the next step after you click OK. It's going to show, I'm sorry, go ahead, Philip.
No, you're good. So in our descriptive statistics is pretty much going to show that our N represents 1700. The statistical data for our standard deviation for females is 0.5 and reading pass level is 0.43143.
Okay, so now when we look at frequencies, our frequencies here is kind of what Philip just said. We have 1,700 that completed this, okay? But when, I went too fast, sorry guys. When we look at our female and male, now you should have a separation of the two. So here, now we're able to see that there were 808 male and that the females was a total of 892, which made up our sample size of 1,700. Okay, so then when we look at our percentages of males represent 47 and 5/10%, and females was 52 and 5/10%. Okay, and then when we look at our reading pass, down here we're able to see that this is not separated by male and female, this is just a total. So with the passing, there were 1,280 students that passed, and with the fail, that was 420 students that failed.
All right. So crosstabs using SPSS. Of course, you hit analyze second descriptive statistics. Your crosstabs. So your females will go into the row, and that is the dependent variable, and is usually placed in that row box. The independent variable is reading pass score, and that is usually placed in the column box as independent variables. You'll go to statistics, and then you will click on chi-square. Since it is nominal, we selected Kramer's V. And just to note, I learned this from the great Dr. Munn, that it is better to run variables that have 4 or fewer attributes, such as sex, gender, race, and appropriate dependent variables.
And we'll give you a few seconds to key that in to your SPSS. So again, step 1, you're going to click Analyze, and then you're going to go down to Descriptive Statistics. Click Crosstab, and like Phil said, we're going to put female under rows, and we're going to put reading passage under columns, and he did explain which was the dependent and independent variable. This is very important, guys, that we click on this statistics, and you click chi-square, and then you're going to click Kramer's V. And then once you click OK, SPSS will do the work for you, and this is the data that you should see now in your output. So question, based off of the information that we see now, how many cases was missing? How many students did not take the test? Or did everyone participate and take this test?
The latter.
It looks like everybody participated.
Yeah.
Yeah,
Yeah.
everyone participated.
And that is important when we're reading the data. We want to make sure that we notate if there are missing cases and if they're not missing cases. And here we're able to see that everyone participated in the reading score. Go ahead, Philip.
Okay, we on the next slide?
No, we're going to go with our counted. So when we look at our male and female count, what was expected and what was actually counted. So here, when we're looking at our cross tabulation, we're able to see what was expected when it comes to male to fail. How many males were expected in the count to fail?
216.
Was it expected 216 or was it expected 199 and 610?
199.
199.
Yes,
199,
that's
sorry.
what is expected, but how many actually fail in our count?
216.
216. And then when we look at our passing rate, how many females were expected to pass?
688.
Was that counted or
Oh, I'm
expected?
sorry. It's 671.
671. So 671 female students were expected to pass, and then 688 of them actually passed. And we might think, when can we use cross tabulation in our day-to-day job? For those of us who are K-12, especially in like an elementary setting, we can use this data in terms of real testing data. So we can look at it and say, just off our observations, we can't say exactly how much they grew or whatever, but we can say, well, the state expected a total of 1,280 students to pass, okay? And then we look at here, how many actually passed? Did it come out at what the state expected? Yeah, it really did. But when we broke it down by male and female, this is where the data was kind of different here. But in the end, once we added it all together, we did what was expected to do. Okay, we won't go into too much depth on the chi-square test, but we will look at this because it is important with cross-tab. Gerald and Tanya will go in more depth with the chi-square test, but here you should also have this on your screen, and Philip will talk to you about our value and our degree of freedom and our asymptotic significant difference here. And what does that mean?
Right. So the asymptotic, asymptotic. Sorry about that. Always get caught up on that. It shows pretty much, without getting into chi-square, shows the p-value. Yeah, sorry. Shows the p-value on the test. Shows the validity of it. So if quick question, what in this to make sure that our value, what is the number that the asymptotic significance should be? Or the p-value.
In the chat, Angela put 0.05.
Right. So 0.05. And then here, our value for Pearson was 0.065.
Can you go back to the previous slide quickly? I don't want to miss the interpretation here. So if we created a hypothesis here, what would that be? Is there a relationship between, can someone give me a hypothesis, a null hypothesis from this? Because I think we do have enough data to be able to create this.
Well, I'll step in because Gerald and I created a null hypothesis
Gotcha.
for the scenario for our chi-square, which was that there is a relationship between gender and past scores for reading.
Okay, I don't want to step on your toes for the next part. So
no, it's okay.
You can proceed.
Okay. And not to go too in depth, but we in our previous class, we already know about the critical value and looking at that and the degrees of freedom. And for a time, we won't go in depth into the Kramer's V or whatever, but we do see our Kramer's V here. And inside of our output, it should have created a bar chart for us. And we're able to visually look and see the frequency of how many males pass and how many female pass reading. And just from looking at this, what can we interpret from our bar chart?
Males are stupid.
Well, we won't necessarily say that they were stupid. We'll just say they didn't get as many questions right as the female. And then here, we have a fail and pass chart, and it's not broken down by male or female. Here is a combination of the two. And we're able to see that there were still 1,700 participants when we look here. Failed plus pass, that would give us our total 1,700, but it also gives us a little bit of data to interpret here that majority of the students pass or majority of the students fail.
Right. And that will conclude our crosstabs.
Pass.
They did, they passed. So once we added those males from our previous slide and grouped them with the females, majority of our students actually failed the reading passage test. And next we'll go into chi-square.
Oh boy.
What was that oh boy for?
No, I'm excited. I love chi-square.
Oh, great. Gerald and I are going to be talking to you about the chi-square test, what it is, why you would use it, and Gerald will be walking you through the SPSS process, and we have a short little video as well. So I think of the chi-square test as a square, you know, people say inside your box. I think about all of my loved ones and people that I hold dear inside one little box, and so that's how I how I think of chi-square is really a test of relationships. So it's used to determine if there is a relationship between two variables, categorical variables. So our null hypothesis for this chi-square, using the scenario in the data set, is the null hypothesis is that no relationship exists between student gender and reading pass score. They are independent. This is a video from Khan Academy. We're gonna, for the interest of time, we'll show a little bit of it, and then Tina, I'll let you know when you can stop it. It's from Khan Academy.
The chi-squared statistic in other videos. Now we're going to use it for a test for homogeneity. And homogeneity or homogeneity, in everyday language, this means how similar things are. And that's what we're essentially going to test here. We're going to look at two different groups and see whether the distributions of those groups for a certain variable are similar or not. And so the question I'm going to think about, or we're going to think about together in this video, is, let's say we were thinking about left-handed versus right-handed people, and we're wondering, do they have the same preferences for subject domains? Are they equally inclined to science, technology, engineering, math, humanities, or neither? And so we can set up our null and alternative hypotheses. Our null hypothesis is that there is no difference in the distribution between left-handed and right-handed people in terms of their preference for subject domains. So no difference in subject preference for left and right, for left and right-handed folks. And then the alternative hypothesis, well, no, there is a difference.
Wait a minute. Tina, please stop.
So how would
my apologies. That was not not the video that I intended to have on there, which was the relationship between two variables. So we're going to skip it, and we're behind on time anyway. But if you would like to know about how to do a chi-square test for homogeneity, you can certainly visit Khan Academy. So I do apologize, but that's okay because we're way over our time. All right, next slide.
Tanya is up for adoption, guys.
I'm so sorry. Well, you know, technical difficulties. We're in the age of virtual learning. We have to just monitor and adjust. All right. So in this case, our problem statement for the chi-square test is, in the sample K-12 data set, respondents were asked their gender, and whether or not they received a reading pass score. There were two answer choices. They either pass or fail. And the researcher wants to test for an association or relationship between gender, whether males or females, and reading pass scores have a relationship using the chi-square test of independence. And we'll use a significance of 0.05. So first, when you are conducting a chi-square test, there are four major steps. The first is to state the hypothesis, which we've already shared, formulate an analysis plan, analyze your sample data, and then interpret the results. So the null hypothesis states that knowing the level of variable A does not help you predict the level of variable B. So the null would be variable A and variable B are independent of each other. There's no relationship. And the alternative hypothesis would be that variable A and variable B are not independent. They're dating. They have a relationship between one another. The alternative hypothesis is that knowing the level of variable A can help you predict the level of variable B. So in layman's terms, as quoting Maurice, that means that if you know that they're a girl, you can assume that they will pass. That's the alternative hypothesis. The null is, it doesn't matter if they're a boy or a girl, it has no relationship to whether or not they'll pass a reading test. So to formulate an analysis plan, you should specify your significance level of 0.05 or any value between 0 and 1, and then use the chi-square test to determine whether there is a statistically significant relationship between two categorical variables. That's the important part. There may be somewhat of a relationship, but in order for it to be proven, there has to be a statistically significant relationship. So then once you've done those things, you're going to analyze the sample data. And using the data set, you have to find the 1, degrees of freedom. 2, you have to find your expected frequencies. 3, use your test statistic, and 4, your p-value. So degrees of freedom are the values that are free to vary in the data sample. They're independent. That's why they're free. The expected frequencies are the probability that the data will appear. Like if you throw a bunch of dye into a bag, or if you roll dye, excuse me, if you roll dye, it's the probability that it'll land on a, what's the probability it'll land on a 1 or a 4 or a 6. So that's your expected frequencies. Your test statistic is the statistic you use to compare your null hypothesis. And your p-value is the probability of observing a sample statistic. Once you have done those things, then you interpret your results. Obviously, we're going to have to do those things in SPSS to get our results. So if there is no statistically significant relationship, the researcher rejects the null hypothesis. This may involve comparing the p-value to the significance level. The researcher will reject the null hypothesis when the p-value is less than the significance level. That's what's been drilled in our head from Dr. Kanuka as well as Dr. Munn, if it's less than 0.05. So I will turn it over now to our SPSS expert, Mr. Hernandez.
Not an expert, but this is what we have learned in this course. Those of you who have fired up your SPSS, we are going to, at this time, run the chi-square test. These are the directions. You're going to open the crosstabs dialog box. You're going to select Analyze, Descriptive Statistics, and Crosstabs. You're going to select Sex as the row variable and Reading Pass as the column variable. Click Statistics, check chi-square and phi Kramer's V, then click Continue. Check the box for Display Cluster Bar Charts and click OK. As we were looking at how we could differentiate and understand the difference between crosstabs and chi-square, one of the things that we came to was that you're still using the results of crosstabs. And what the purpose of chi-square, once again, is to take those results and see if there is a statistically significance in that data. Next slide, please. When you pull up the results from this data set, you should see the following tables. If you'll take a look at the sex reading pass summary chart at the top, you will see that, once again, how many respondents were in this data set.
1,700.
So 1,700, again, that makes up the males and females. If you look at the cross tabulation summary chart down there, you will see, once again, using these variables of reading pass and gender, once again, how many of the female students did fail?
204.
204. How many of the male students passed?
592.
592. If you were to look at this table at this time, would you categorize it and label it as a 2x2 table or 3x3?
2x2.
2x2.
Okay, and so as a rule of thumb, when it comes to looking at how we identify the table and we're looking at effect size afterwards, will we be using phi or Kramer's V?
Kramer's V.
Phi.
Phi is correct. So 2x2 is phi, and if you do the 3x3 or higher, you'll have Kramer's V, of course. As you move forward, and we're going to look at what is the most common way to look at effect size, of course, we're going to look at Cohen's D. Cautiously, we do use which numbers when it comes to Cohen's D as a large effect size. Does anyone know what the large effect size would be?
Not without looking at that table.
Okay, so recalling from his reading, if for overall, again, this is using
1
cost.
to 20, 20 to 50, 50 to 80.
Okay, there you go, Tina. Thank you. Awesome. So once again, as we look at this, these results on the next table, if we were to look at the approximate significance right here, how would we once again label this significance using what Tina just told you?
Throw this away.
Throw this away. And so throw this away when we're going back to the null hypothesis and we're going to throw this away. What did you mean by that, Maurice? Throw this away.
It's not less than 0.5, so you can't reject the null, so you have to fail to reject the null hypothesis.
Awesome, awesome. Okay, next slide. Right here, we're gonna look at, once again, the bar charts right here. To the naked eye, if you were to look at this data, would you be able to say what the significance was in this data set by just using the bar chart? Or would you have to look at, once again, the asymptotic results and the effect size or the p-value? Would you just use this bar chart to determine significance?
You can see the significance.
So if you were looking at this bar chart with your naked eye, could it possibly lead you to believe that comparing males and females, that there was a great significance?
Not a great significant, but a significance.
Yes. So in every test, what is very important is that you look at all results of the chi test to determine if there is a true significance when it comes to this. Once again,
A statistically significant difference.
yes. Once again, when looking at the results of chi-square, one of the things that's very important to know about this is that we don't make assumptions about the shape of the population distribution from the sample that has been drawn. Also, when it comes to the chi-square, we're actually looking at evaluating to what extent the data and the hypothesis have a good fit together. Next slide, please. Since the p-value is greater than our chosen significance level, 0.05, we fail to reject the null hypothesis. Rather, we conclude that there is not enough evidence to suggest an association between the gender and reading pass score. Based on the results, we can state the following. There is not a statistically significant relationship between gender and reading pass scores. There are some limitations when it comes to the chi-square test. For example, we do not give as much information about the strength of the relationship or its substantive significance in the population. There is also the chi-square test that is also sensitive to small expected frequencies. Next slide. Oh, that was the final slide, sorry.
So will the 5th grade team receive that that requested purchase for the media center of all of those books? Did they prove with the data that the boys needed more reading materials?
They did not.
I have a question. I'm sorry, I got a little bit lost just at this, and I just want to talk it through beginning to end really quickly. So the null hypothesis was that there is no whatever. So if we fail to reject that, doesn't that mean that there is a relationship between gender and reading pass?
No, if we rejected it, then there would be a relationship. We're failing to reject it. When you fail to reject it, you accept it.
Yeah.
Gerald and I had about a 20-minute argument and debate about that because it confused even me when we were talking through the presentation, and I was ready to go, yay, the team gets their books. And then I was like, wait a minute.
Yeah.
So really it is a little bit confusing, the terminology. So when you fail to reject the null hypothesis, that means you're accepting it.
Yeah, the null hypothesis coming into this problem is that there is no relationship. So just imagine taking the contrarian's view and saying, hey, there's no relationship here. You know, there's nothing going on here. I don't believe we need to spend this money. And so then you run this test, and this test says, oh yeah, there's no real relationship between gender and reading scores. So I fail to reject this contrarian view that there's no relationship that exists there. Does that make sense?
No, but we don't need to.
No. I want you to get it. So
Even
again,
if you're starting with there is no relationship.
Mm-hmm.
So
no statistically significant relationship.
Hold on. Let me.
Can y'all hear me?
Yeah, we hear you. Go ahead.
I was just talking away, and I'm like, did you hear me? Okay, so look at it this way, Maurice. We're basically agreeing with the hypothesis. Even though you see that fail and you receive the reject, you think that's a no-go. But just look at it in terms of saying whatever that hypothesis that group one told us about when we researched our problem and came up with that question, whatever they suggested, that's what we agree with based off of the p-value. Now, if it was different, then we say, okay, wait, no, there is a significant difference. But because the p-value was greater than that nickel is what I like to call it, then we're saying that we failed to reject the no.
And if it's significant, then the hypothesis is rejected.
Right.
And state that there is a relationship.
Yes, that there is a relationship.
Mm-hmm.
And that's why we couldn't just look at the bar chart graph, because if we were just looking at that bar graph chart, we'd be like, oh yeah, there is a significance. But the other thing about the bar chart is, and I'll go back to, well, we won't go back for time, but when we think about standard error, which we don't really talk about a lot in that standard deviation, when it comes to standard error, and I think you think about it with the data, if there were more girls that took the test than boys, we have to look at that standard error. And so therefore, we can't just look at a visual and say, well, yeah, there's a significant difference. Well, girls had a better chance of passing than the boys did in terms of number-wise, not terms of capability, but because they had more participants, their standard error was way much larger than the boys. I hope that kind of makes sense without having to go back and show the actual bar charts.
That does, for me at least, and you know, I'm sorry, it's really good. Okay, any more questions?
I would just like to say that I will post the appropriate video after class. I will post it on Canvas.
And I believe, Dr. Munn, summing up the chi-square values,
Mm-hmm.
of course, similarly, they have values that indicate high probability and low probability. And what I learned from the high probability was also that those are like of chance, just random chance alone.
Mm-hmm.
So that was a big part of chi-square as well.
If there aren't any more questions, for the interest of time, I know I seem to give a lot of really positive feedback and not too critical. That's because this is really tough stuff, and it seems that you all have a really good grasp on it. You took your time and you worked very hard. So trust me, if this was not good, I would tell you, because at the end of the day, I want all of you to be able to walk out of this class and be able to see the world a little different, understand statistics, understand when people start running around and throwing around, you know, standard deviation and terms and stuff and bar charts, as you said. We're going to see a lot of bar charts between now and a lot of graphs and a lot of scatter plots between now and November 3rd. And hopefully that whatever you all have picked up in these last couple of weeks will help better prepare you to discern what you're seeing, what you're hearing, and then obviously what you're able to do in your day-to-day work. So I really appreciate both of these presentations were really, really good. You all asked good questions. And I always want folk to ask questions so that they can stay engaged during the whole process. It's easy sometimes to sort of float away after you've done the presentation. So I want you all to stay engaged. So thank you for paying your team members, your colleagues, the appropriate respect for their work. With that, obviously, I'm not going to go into ANOVA today. We will tack that on to the beginning of the lecture next week. So at some point, we're going to get to ANOVA. But yeah, just a job well done for each and every one of you. I appreciate the work and the camaraderie that you all have been able to show and just getting it done. I do hope this was helpful in reinforcing the concepts needed for us to move forward as you get closer to understanding more statistical applications, and then obviously the final project. The reason I paired you up in groups was because a research proposal, I found that working with people you're at a point now where group work is not leaving someone hanging, but actually a collaborative experience and something that you can build upon. So you obviously you do less work, but at the same time you're working together. And in reality, if you're employing statistical analysis and as a principal, as a superintendent, other folk are going to run the numbers for you. You're going to have to make the decisions. You're going to have to make the interpretations and ask the questions. So that's why the group work is so important. I don't feel like you have to do it all by yourself, but the group concept is incredibly important as you rise through the ranks as education leaders. And I see many of you being able to matriculate, being school board members and superintendents at some point, or whatever it is your desires might be. So I'm going to quit babbling.
I have a question.
Sure.
I didn't do the last video assignment. So the question is, can you open it back up?
Heck, man, you were on point, man. Now you're going to fail, bro. I got you.
Well, he extended the one that was originally due to today. You're not talking.
Send me an email with your request, and I'll go from there. But cool. If that's all for today, we'll break a little early. And again, thank you for your hard work. And if you have any questions or anything, just follow up with me via email.
Have a good one.
Have a great one now.
Dr. Munn.
Yes, ma'am.
That video was my portion. Please don't count that against anybody else. I'm absolutely mortified. So please, that was my responsibility. So and I will send the corrected one.
Okay.
Sorry, group.
Noted. Take care now.